Ladies and gentlemen, we are on the last day of week 11, electrons and energy. We're going to finish up with potential energy today. So, our learning target, we will be able to solve for gravitational potential energy and recognize other forms of potential energy. This diver has just jumped from the end of a diving board. After she dives down and is falling towards the water, she will have kinetic energy, or the energy of moving matter, as we talked about last time. But even as she is momentarily stopped high above the water, she has energy. Do you know why? The diver has energy because of her position high above the pool. This type of energy she has is called potential energy. Potential energy is energy that is stored in a person or object. Often, the person or object has potential energy because of its position or shape. What is it about the diver's position that gives her potential energy? Pause the video for a moment and think about this. Write down your answer and see what you come up with. Do you have an answer? Great! Let's check it. Because the diver is high above the water, she has the potential to fall towards Earth because of gravity. This gives her potential energy. Gravitational potential energy is the potential energy due to position of an object in relation to Earth's surface. Like the diver on the diving board, anything that is raised up above Earth's surface has the potential to fall because of gravity. You can see another example of people with gravitational potential energy here. Gravitational potential energy depends on the object's weight and its height above the ground. It can be calculated with the following equation. Gravitational potential energy, or GPE, equals weight times height. Consider the girl on the sled. She weighs 140 newtons, and the top of the hill is 4 meters higher than the bottom of the hill. As she sits at the top of the hill, the child's gravity potential energy is 40 newtons times 4 meters, or a total of 560 newton meters. We can also call this 560 joules. A joule is a newton meter. Notice that the answer is given in newton meters, which is the SI unit for energy. A newton meter is the energy needed to move the weight of 1 newton over a distance of 1 meter. A newton meter is also called a joule, as we mentioned. Now let's look at the gymnast. The gymnast is on a balance beam and weighs 360 newtons. If the balance beam is 1.2 meters above the ground, what is the gymnast's gravitational potential energy? Her gravitational potential energy would be 360 newtons times 1.2 meters, or 432 newton meters, or 432 joules. You'll notice that the little girl on the sled has much more gravitational potential energy than the slightly older girl, who actually weighs more, does on the balance beam. This is because the little girl is so much higher above the surface of the Earth, 4 meters as opposed to 1.2 meters. Potential energy due to an object's shape is called elastic potential energy. This energy results when an elastic object is stretched or compressed. The farther the object is stretched or compressed, the greater the potential energy is. A point will be reached when the object can't be stretched or compressed anymore. Then it will be forcefully returned to its original shape. Look at the pogo stick. Its spring has elastic potential energy when it is pressed down by the boy's weight. When it can't be compressed anymore, it will spring back to its original shape. The energy it releases will push the pogo stick and the boy off the ground. The girl is giving the elastic band of her slingshot potential energy by stretching it. She's holding a small stone against the stretched band. What will happen when she releases the band? Well, from your experience, I'm pretty sure you already know. that the elastic band will spring back to its original shape. And when that happens, watch out. Some of the band's elastic potential energy will be transferred to the stone, which will go flying through the air. All of the examples of potential energy described before involve movement or the potential to move. The form of energy that involves movement is called mechanical energy. Other forms of energy also include potential energy, including chemical energy and nuclear energy. Chemical energy is stored in the bonds between the atoms of compounds. For example, food and batteries both contain chemical energy. Nuclear energy is stored in the nuclei of atoms because of the strong forces that hold the nucleus together. Nuclei of radioactive elements such as uranium are unstable, so they break apart and release the stored energy. In summary, potential energy is energy that is stored in a person or object. Gravitational potential energy is due to the position of an object above the Earth's surface. The object has the potential to fall due to gravity. Gravitational potential energy depends on an object's weight and its height above the ground and can be calculated GPE equals weight times height. Elastic potential energy is due to an object's shape. It results when an elastic object is stretched or compressed. The more it is stretched or compressed, the greater its elastic potential energy is. Chemical energy and nuclear energy are other forms of potential energy. So, are you now able to solve for gravitational potential energy and recognize other forms of potential energy? If so, congratulations. You can move on to the next activity. But if not, take the time to go back and see this video one more time. I hope you have a great week, and we'll see you again soon.